Okay, I'm just going to show you kind of the basics because I'm not exactly sure what it is y'all are having trouble with, but I'm just going to kind of show you what I think. Sorry, I accidentally paused it. So the two formulas that you need to know that anytime you take the derivative of a natural log, you're going to have the natural log function and then some other function inside of it. And we'll call that a function on the inside u. So the derivative of the natural log of u is u prime over u. Just means you'll take the derivative of u and divide it by u. And for logarithms that are not natural logarithms, it's very similar. These are just logarithms with a base other than e. Remember, natural logs have an understood base of e. But you can have other kinds of logarithms with other bases. So it's very similar to the u prime over u, but it has something extra because of the different base. It's 1 over the natural log of the base, so the base of your logarithm, times u prime over u. So very similar. So just some kind of basic examples. Let's say you wanted to find the derivative of this function, the natural log of, we'll say 2x squared minus 3. Then the derivative of that, if this is u, is the derivative of this over this. So the derivative of 2x squared minus 3 over 2x squared minus 3. So that would give me 4x over 2x squared minus 3. Similarly, if it had said y equals log base 3 of 2x squared minus 3, the only real difference would have been that we would have had 1 over the natural log of 3, since our base here is 3, and then times u prime over u. So very similar. So I imagine that you really have problems with actually plugging into the formula for basic functions like this. What your problem probably is when the functions get a little bit more complicated. So I'm going to show you one, and then we'll kind of see, and y'all can let me know if there's something else, maybe a specific problem or something you want me to work, and I can make another video. But let me just show you a problem that might give you more trouble than these. So, oh, here we go. Okay, so let's say you have the function, whoops, the natural log of, let's say, negative 4x to the 4th over 3x squared minus 7 to the 5th power. Right? So you're supposed to use u prime over u. But if you look at this u, this would be a nightmare to take the derivative of. It's a quotient raised to a power, so you're talking about the chain rule and the quotient rule, and then after you do all that, you still have to divide it by itself, which itself is a fraction. It's a mess. So what you should actually do is rewrite this first using your laws of logarithms from pre-cal. So the rules for logarithms, there were 3 of them. There was what's called the power rule, and that said that if you had the log of something raised to a power, you could move the power to the front. And that applied to regular logs as well as natural logs. And then there was, whoops, hold on. There was the product rule that said if you had the log of a product, you could split up the product by writing it as a sum. And then there was the quotient rule that said if you had the log of a quotient, you could split it up by using subtraction. So on this one, I would actually use the power and the quotient to rewrite this. So let me show you how that would work if you rewrote this using those 2 rules. So let me erase this and show you what you can do with this. All right, so if I rewrite this using the power and quotient rules, I can rewrite it like this. First, I can move the 5 to the front of the log. So I have this 5 times the natural log of negative 4x to the 4th over 3x squared minus 7. Then I can split up this quotient. So I would have this 5 times the natural log of negative 4x to the 4th minus the natural log of 3x squared minus 7. And you want to be sure you put the 5 outside the parentheses because the 5 actually goes to both, because in the original problem both the top and the bottom are being raised to the 5th power. So you want to make sure you do that. So now we can take the derivative. So we would have 5 times the derivative of the natural log of negative 4x to the 4th. So this would be our u in this logarithm. So we would have 5 times the derivative of this over this, all right, minus 5 times the derivative of this over this. All right. So here we would get, I'm running out of room here, 20x, no, 20 over x, all right. There's 1x left on the bottom. So 20 over x minus 30x over 3x squared minus 7. So you're going to want to rewrite logarithms using those properties of logarithms before you take the derivative, because you don't want to end up having a derivative that has fractions in it and then a function that has fractions in it. So you've got this complex fraction that you have to simplify. So let me know if that helps. I don't know if that's what y'all are having trouble with, but if it's not, I'm more than happy to make another video working a specific problem or problems that you're having trouble with.